Think about the apps you use on a daily basis. Instagram, WhatsApp, TikTok, Audible, which we'll come back to, etc. Now think about how many of them are unreliable. The answer is none. Would you use a calculator that is only 50% reliable? No, of course not. So why do you have this expectation that it's okay for consumer AI apps? The reason, I believe, is because we don't know how big of a problem it is, and you don't know what you can't measure. Welcome to Beyond Reality. My name is Kiran Prasad, and I'm your host as an ML architect at Ario. And I will be walking you through how you can measure simulated user experiences, because you don't want the real thing, which causes user attrition. And we're going to do this through templated LLM evaluation and synthetic data generation. So you may be asking, Kiran, why do I need any of this at all? I just want to go and test stuff and spend more time building my application, right? Well, those who do not study history are doomed to repeat it. And so here we have a history boot camp. Get it? Boot, like booting a disk. Anyways, I promise my presentation is much better than my jokes. And so looking at these three prongs of the Beyond Reality framework of testing, metrics, and simulation, let's look at the history of testing first. So prior to 1957, the only form of testing that was done was debugging. And fun fact, the term debugging comes from Grace Hopper, who is a pioneer in computer science back in the 1940s, when her and her team had a moth that had gotten into a computer at Harvard and had caused havoc, right? And so that is the origin of the term debugging. Fast forwarding about 30 years from the 1957 checkpoint, if you will, where debugging and was going out and testing was coming in, we have the 1983 standard that was released about how to standardize testing documentation. And this was a milestone because it was a coalescing of the community and marked that testing was really important for software development, right? And one critical thing about tests is that they're all expected to pass, which is quite different from metrics, as you will hear shortly. And while there are many different types of metrics, the origin of metrics that I think tells the story the best is from its early roots in signal detection theory, which comes from radar, which was used for in World War II extensively and was used in order to detect friend from foe, etc. And so if you're familiar with the ROC curve, or the receiver operating characteristic curve, that was used as a way, after plotting the true positive and false positive rates, to go and see what the optimal balance between friend and foe was. And so one important thing to realize about metrics is that perfection is never expected. In fact, if you achieve perfection, you probably have an issue in your metrics. And this is called saturating the metric, because it is not a set of problems that you expect to be able to completely and utterly solve, because there are fundamental constraints. And finally, we can talk about simulation, which is the third prong. And so for simulation also originated in around World War II as a way to understand the behavior of complex systems for which there was no closed form analytical solution. And closed form analytical solution is math mumbo jumbo for what in computer science terminology could be rewritten as statically and explicitly writable or written. And so you may be asking, what is the point of this history boot camp? And what is the takeaway? And I would tell you that the takeaway is that World War II was clearly critical for computer science technology development. No, I'm just kidding. I would actually say that evaluation should reflect the expectations of the software is the takeaway that you should be able to remember. And I'll say it again because it is really important that evaluation should reflect the expectations of the software. Now, what is evaluation? Evaluation can be described with a very simple function of the input, the task, and the output. And I promise this is the only math in the whole presentation. And so you may be asking, what is the input? Well, the input is the context that you're giving your AI application, right? It may be the posts that someone has liked. It may be some documents that you've retrieved. It is whatever the context is in addition with your user's request or message, right? And the task is what is your application actually doing? And finally, the output, which is self-explanatory, is really what is the outcome of your system, right? And so I thought I'd make things a little bit more fun and have a personal assistant that recommends books called Buy, who's your little book matchmaker, and he's going to be our running example buddy through these different frameworks that we will go through, right, of testing, metrics, and evaluation. And so Buy will take the context of the books that you've read, either via Audible or via Kindle or posts that you've made that are related to books, basically all of the context around your books, and use it to provide a very concierge service to you in order to give you the best recommendations and service that's possible. And one important note is that Buy does not currently support recommendations for children, though this feature is indeed coming. And of course, Buy is totally fictitious. So going to the first of the three pillars, we want to talk about testing. And I know that most of you are familiar with testing, but I want to go through two main forms of testing that are relevant here. The first is static testing, where there is no contingency on the user data and where there is a question and an answer that you know that is only dependent on the question, right? And so in our Buy example, a user may ask, who wrote the Harry Potter series? And for those of you that are familiar with Harry Potter, you know that the answer is J.K. Rowling. And if we look at our pseudocode for how the evaluation is done, we check to see if J.K. Rowling in some form is indeed the answer. And of course, Buy is a good application, so we pass. And the structure of this talk will be that each one of the testing paradigms or frameworks will be will supersede the previous one, right? And so as we keep going, they will be able to evaluate things that the previously described ones are not able to. So the next example and the last example within testing is dynamic testing. And clearly, static testing was very limited, so maybe dynamic testing will be better, right? And so in dynamic testing, we do have a contingency on user data. So you can see there's a little blurb based upon what I like. And the most recent book I read, which was The Hitchhiker's Guide to the Galaxy, it's quite good. I recommend it if you're into fiction, goofy fiction. And I ask, what book did I last read? And Buy answers correctly, The Hitchhiker's Guide to the Galaxy by Douglas Adams. And dynamic testing is as simple as checking to see, is that correct or not? But of course, this is now particular to the user's data because there is no universal answer for what book did did I last read? And so we pass here, but we realize that there may be some limitations that are at play. And so I want you to think about those as we move on to metrics. And when we talk about metrics, you will see some of the limitations in the testing framework come up. But an overview of testing is that we expect 100% of them to pass. And as you know, they are binary, so it's either pass or fail. And they're canonically single reference. What that means is that traditionally, you are looking for a single answer that you are asserting by, right? And so in software engineering, you expect a particular set of behavior, and you don't expect much variance in this behavior, or you test every one of the cases, right? And this is generally true in this type of testing as well. And so moving on to metrics, when I was on Microsoft Turing and we were building Copilot, metrics were paramount in being able to give us insight into how we were doing on this journey of building, right? And so the first metric that I'm going to talk about is what I'm calling static metrics, which are a type of referenced metric because you have a reference and you have the generated output, and you're looking at how similar the two of them are. And the more similar, the higher the score. And so right off the bat, you see it's a metric because it isn't right or wrong, but there's gradations, right, based on the similarity. And there's many such examples of this, one of which is Rouge, but there's lots and lots of examples of these, right? And so now we see that I ask a question that would not be suited to the tests that you've seen previously of, do you think I'd like the Foundation series by Asimov? And Bai has a great answer that's quite descriptive, actually a little bit more descriptive than my reference answer that you see in the pseudocode. And so when we look at the similarity of the reference answer, which is you would enjoy the Foundation series by Asimov, with the longer answer and more descriptive answer by Bai, we start to see some of the early issues with the static metrics, right? Because you get a decent score because you have the enjoy the Foundation series as a substring in both, but the all the detail that we actually like is not only not rewarded, but it ends up being implicitly penalized by this measure of overlap, right? And so we can start to see some of the cracks in static metrics as well. But static metrics will fall flat on their face in the following situation, where I ask, which fiction book do you think I would like? And suddenly there's many right answers, right? You could recommend Dune, you could recommend Lord of the Rings, you could recommend The Hobbit, you could have recommended 1984, etc. And so from this, you can see that the static metrics, because they have a single reference, are not going to suffice, right? Even if you had a list of references, it probably wouldn't suffice because there's likely many, many correct references that you could get. And so here is where reference-free LLM evaluation really shines, right? Because here we have an LLM that's tasked with going and seeing if Bai's answer is reasonable given my request, my query, and my data, and then it's graded. It's graded based upon those, right? And there is no reference, and this is indeed reasonable, and so we get a good response. So far, Bai is doing well, and also reference-free LLM evaluation seems to be working quite well too. But if we look closer, we can see that there may be some problems in reference-free LLM evaluation, particularly around the modularity and also understanding the task, because LLM evaluation is doing a really good job of understanding the output, but it's maybe not understanding the task so well. So let's take a look at templated LLM evaluation. So in templated LLM evaluation, we can see that my question is quite targeted because you'll remember that Bai does not support recommendations for underage folks or children, etc. And so when I ask for a book recommendation for a gift for my young nephew, Bai correctly says, I'm sorry, but I cannot do this, right? And here is where normal LLM evaluation gets dicey, because there is a non-negligible chance that the LLM evaluation will go and say that this was a bad answer because it only sees the input and the output, not the task, right? If you remember our equation. And so in templated LLM evaluation, we also give the task dynamically so it never gets stale at the time of grading. And this can be done by passing in the prompts that Bai is using, or by passing in a summary of the code that Bai is using, etc. But the key point is that the task is also given, hence the word templated, right? Given dynamically. And so now the LLM has the context of the output and the task and the particular input that we have. And so it correctly says that this is good. So this is working really well, right? But the thing that we're still missing is that the input side is not as varied as it could be. And so we're going to take a look at that shortly, but let's do a little summary of metrics. And so with metrics, we never expect metrics to pass 100%, because if we do, as I had mentioned, then we would consider the metric to be saturated, and we probably need to get a better test set that we're trying to test our metric on, right? Test our system on. And they're also more flexible than the normal unit testing kind of framework, and they aren't Boolean, etc. And finally, it really solves the problem in our evaluation equation of the output and the task. But as I had alluded to earlier, it doesn't properly address the input. So how are we going to address the input? Well, I had this idea of user simulation when I was reading this paper called Generative Agents by June Park that came out a little while ago. And so in this paper, the idea is that basically they go and they model a little city where each person in the town is a individual with a persona and is a separate LLM agent that are talking to each other dynamically, right? And this was quite an interesting idea. And so you can see here, John is saying, hey, have you heard anything about the upcoming mayoral election? And Tom says, no, not really. Do you know who is running? And as an example on the right, this is the type of thing that the LLM would be seeded with so that it has an idea of the character it's playing, who is John, right? John is a pharmacy shopkeeper, And so this got me to think about why can't we do this for our target persona? Because at startups, we generally all know our target persona and we want to be able to build for them, because again, we want their experience to be good, because users care about their experiences. They don't care about your metrics. And so I decided to create Generative Kiran along with the generative image. And so here I have a short description of myself as an ML architect, Ario, who described himself as a philosophic adventurer, etc., etc. And then at the end, I say, I recently returned from an enjoyable trip to Argentina with my parents, which will come into use over here. And so what we see is that we are trying to have an LLM go and take a seed of a target user and model that user, simulate that user when interacting with your application, so that that interaction, which is going to be personal, can be graded with templated LLM evaluation, right? So we're trying to solve the input side of that equation. And so in this example over here, simulated Kiran goes and asks that, what Argentine literature would you recommend? Because I recently came from a trip to Argentina, right? And Bai answers with a classic of Jorge Luis Borges and says he's one of Argentina's most famous writers. And simulated Kiran can then respond, which is key because we've never seen a response before in this kind of multi-turn setting in this presentation of, oh, what does he write about? And then Bai answers appropriately, right? And the key thing here is that, one, we can have a deeply personal interaction because each user is being modeled, or each one of the users in your target personae are being modeled. And those models are actually going and interacting with your app from the point of view of being that person, right? And this leads to very, very personal, bespoke interactions that more accurately represent the interactions that your users would have, because users care about their experiences, they don't care about your metrics. And so with the templated LLM evaluation, we then go and take this multi-turn conversation, because now we can actually grade a multi-turn conversation, because we don't have to think about this combinatorial explosion, or exponential explosion in possibilities as you have more and more turns, because the agent is responding as though it was a user. And so you can actually grade the whole conversation in the context of what has happened, and with the context of the task and all of the outputs, right? And so in this case, this is great. We get a very personal we have a very personal dialogue, and we get to grade that perfectly, right? And so this is really trying to combine everything. This combines the simulation of the users, which is just having a separate agent that is trying to model the users by having a prompt similar to that paper. And it is also then having that agent that's simulating the user interact with the application in a dynamic back and forth manner. And so we really get something that is pure and as close to the user's experience as we can, which is critical, right? And so overall, if we were to take a look at this approach of beyond reality, right, trying to simulate the users and use templated evaluation to grade that and evaluate it, we go back to our principles of you don't know what you can't measure. And so we have tried to start to measure this. Users care about their experience, not about your metrics. And so we are trying to model their experience as opposed to creating metrics that may or may not correlate with their experience. And finally, the evaluation needs to evolve to meet the expectations of the software, right? And the expectations of use for AI apps is through the roof. We expect AI apps to be personal, to be contextualized, to be intelligent and innovative, and all of these wonderful things, but our evaluations need to meet those expectations. And this is at least an attempt to do that. And so thank you very much for listening. I really hope that you got something out of this talk, and this can maybe inspire you to try something along these lines yourself. Again, my name is Kiran Prasad, and I'm an ML architect at Ario. And if you want to dive deeper into our technical details, we have a technical blog where we write about these things and more. So please go check that out. And if you have some comments or concerns, etc., on anything I've presented, or you just want to connect, feel free to connect with me on LinkedIn or put a comment down below. And once again, thank you so much for listening.